All right, guys, I am going to finish up this section. It should not take very long today. I've got a couple of examples, and then I think we're going to, at the same time tomorrow, try Zoom. My goal is to allow you to ask questions in real time. Hey, Caitlin, to make sure that um, you are able to talk back and forth. So please check for that code in Google Classroom so that we can all kind of try that out and see what we think. Hey, Daniel. Hopefully that could help us ask questions and feel a little bit more comfortable. What I would also like to encourage you to do is still, if you're having any issues with questions, take screenshots in on your computer or with your phone and email me those pictures so that I know exactly which ones you're having issues with. I know I go in and I check the no-read problems before I assign them to make sure that what I'm giving you kind of corresponds with what you're looking at. I'm trying to make sure that the study guides that I've given you in Google Classroom resemble the questions that you're also going to see on the no-re account. And like you saw yesterday, I kind of gave you a brief outline as to what you're looking at. What you're looking at hopefully will help with the study guides and get through. Now I see, Beth, you made a comment that you're having trouble getting worked in with other teachers with Zoom. Is it the video that they're trying or just audio? Or is it possibly just connecting? I'm curious. I know I've done it with fellow teachers and with a full meeting, and it seems to have worked quite nicely. I've done it just to practice with a few friends before I would even try it with a class to see how that would work, and it seems to have worked well. I did sit in on a class this morning just to see what students would do. It appeared, and this is just from an observation, that students were having issues just knowing where to go and where to click. I know you can mute and unmute yourself so that you can hear. I'm just curious. Now, I do know that you have to use Chrome. Google Chrome is definitely something that you would want to use with pretty much, I guess, now anything nowadays. Safari doesn't seem to hold up very well with some of the links or processes. Logging in for some, and Rini couldn't hear anyone, but she said that the tech guys are working on it. Okay, that's good to know. I'm wondering if it's something on your computers, but yeah, definitely Mrs. Rini would get that taken care of very quickly. I know when I watched this morning, some of the issues were very simple, like turning the volume up on the computer with the buttons at the top of your keyboard, as well as making sure when you clicked on the Zoom link, there was a button to say use your computer's audio. So I'm not sure if that may have something to do with it. I do want to try. I think that would help. I would love to hear some of your voices and to be able to talk in real time. And maybe it's something we try and we find we like, and we can do it once or twice a week. Hey, Donnie. So just kind of keep a heads up. I'm still going to record everything. And if for some reason it doesn't work, I'll go live and post what we need, and we'll go from there. So for right now, just keep an eye on Google Classroom for all of our updates. But truly, ladies and gentlemen, take screenshots, email me the questions that you are having so that I know which particular questions that you have. I know sometimes the explanations might be a little unclear, so I can always handwrite them too, or even address them via live stream. I've done that with other classes, and it seems to clear up any problems right away. So with that being said, I do want to go ahead and take a look at the next couple questions. It is just to finish the section. It is one concept, and then we'll be done for the day. So this idea of similarity and triangles increasing or decreasing, we kind of get the idea now that one might be twice as big as the other, one might be a third as big as the other, or it could have some crazy relationship like 7 to 5, whatever the common factor was. One increased 7 times the size, the other one only 5 times the size, but it all went at the same rate. And we did show right away at the beginning of this chapter that whole Honey, I Shrunk the Kids Ant-Man idea, where this does play into those things. So this idea of similarity in segments, I think, is interesting because they have a whole part of the section that talks about, well, what about these segments that fall inside the triangles? How are they going to relate? And this is something that I always think about, and I don't know if you guys have ever played with these expandable, I guess you could say, balls or polyhedron if we really want to get geometric with this, but where you can pull them out and then condense them. And that's kind of what I think about when I think about this section, that when this ball gets pulled apart, notice how all the pieces would have moved with it, and then it's one solid figure. And then when we put it back together, it would collapse. Now, I'm not saying in any way, shape, or form that these are similar objects. What I am saying is when we pulled this guy apart, notice how their pieces didn't kind of dangle in the middle, like they didn't expand with it. It did move with it so that it would have the same rate of increase or rate of decrease when it went back together or when it was pulled apart. And you can see this first one right here, you can see kind of vaguely, and I know it's faint, the guy is condensed right there, but then pulled apart here, and all of those pieces went with it. You didn't see any broken pieces kind of dangling off to the side. So that's really what's happening here. We're looking at this as if this triangle decreased, everything about it would decrease at the same rate. So the segments inside, for instance, here, let's finish this picture off as I redrew this morning because I wasn't happy with the way it looked. In this picture, we have this guy right here and its counterpart over here are actually medians. And we talked about medians and altitudes and angle bisectors in the last chapter. Doesn't really matter what they are, they're just segments inside the triangle. And those scale factors will match. So these medians, they'll have the same scale factor as the sides. And again, the only reason we even talk about scale factor is because we are talking about two full shapes. Again, ratios we can use all the time, but when we talk about scale factor is specifically because we have two triangles. So when we have these two triangles, I can see right here that they're telling me what corresponds. I don't have to guess. I don't have to look necessarily at the tick marks. They're telling me right there in the given statement what corresponds. And if I had to, I could write a proportionality statement based off of this. AB matches with EF. BC matches with FG. And AC would match with EG. And so these are still concepts that we talked about in the very first section of this that are coming into play still. We just don't write it out every time. So when I look here at AB is 22, I can see that it's going to match with EF. Well, can anybody tell me right away, just from using a little bit of common sense and logic, what's X going to be? How much is X going to be? And here's where, of course, using Zoom could come in handy if it worked appropriately. I would be able to hear your answers. And of course, if you didn't want to say them, you could still type them in just like we do here. Nobody wants to take a guess at what X could be? If this guy is 22 and this guy is 11, awesome, thank you. And it's true, because you could always set up our 22 to 11 is equal to X over 5. Nice. I know, I'm really horrible still with this timed delay. It doesn't seem like 20 seconds is that long, but it is. Now, of course, it'd be a lot easier if I did change it to the scale factor, where if I reduced, we know that everything should be 2 to 1. And that would make that a lot easier to deal with instead of cross multiplying and having to worry about 22 times 5 and 11 times X. Either way, we end up with the fact that, oops, and I did 2. Good gravy. Come on, Cafaro. Got carried away with my 2's. And we end up with X equals 10. See how much nicer it would have been if I would have used the scale factor instead? So it's not going to change. The medians, or our segments inside our triangles, will have the exact same scale factor as the side. So all of it will correspond. So that one was a little easier to see. And because we recognize it, honestly, answer the question, move on. You don't even have to show all of that work if you don't want to. So then let's take a look at the next one. Nothing's going to change. It's exactly the same concept. The only thing I did differently here was I just changed what the segments were. So instead of us calling them medians, this guy right here and its corresponding piece right there, those are altitudes. Now, whether we remember what they're called or not doesn't matter. They are still going to share the same scale factor as it would have if it was a side. Now, this time I don't have a given statement, so I am going to do a little bit of writing to remind you. So, no given statement giving us the similarity statement. And remember, similarity statement means triangle similar to triangle. So what that means is you must look at the tick marks. You have to make sure you check your tick marks to know what corresponds. So if you don't see a similarity statement, just make sure you're looking for the tick marks to make sure you know what goes with what. So of course, over here I have 18, 14, and 10. And then over here I only have 2 and X. Clearly, we can see what goes with the 2 because they're both now inside our shape. What does X correspond with? What does X correspond with? Perfect. X is going to correspond with 14 because what I'm looking at is I have a double tick mark here and a bar here. I have a double tick mark here and a bar here. So because, awesome, thanks guys. But I also wanted to make sure that we kept everything straight. Even though X is over here, I need to make sure that if I set up my proportion, I keep everything from this left or bigger triangle on top, everything on the right or this smaller triangle on the bottom. So I'm going to put 14 there, and I'm going to put x on the bottom. Now, I just want to solve for x. It didn't ask for a scale factor. It doesn't ask for anything else. So I am going to cross multiply, and I do end up with 10x equals 28. So we end up with x equals, could do 2.8. It is the same thing as 2 4/5. Doesn't matter. Just make sure you know that you can go between the two. Now, if I did ask what the scale factor was, and it doesn't matter at this point yet which way we write it, our scale factor, again, would be this 5 to 1. And it does make it nice that we had that 10 over 2 that we were able to talk about. And that does give us this 5 to 1. Now, doesn't look like it's 5 to 1 when I have the 14 over this. But what I can do to double check is grab my calculator, and on my calculator, 14 over that fraction, so 14 ABC, and then, or let's do the divided. 14 divided by, and then in parentheses, I'm going to do 2 ABC, 4 ABC, 5, and close that off, and it does give me 5, which is the same as 5 to 1. I could have done 14 divided by 2.8 and still found that it was 5. So I can check to make sure that this is in fact equal and that I do end up with the same scale factor if that was the question. So nothing's changed. We just want to make sure that we remember that all of our segments inside are going to have the exact same scale factor as what we've been working on. Any questions so far? I'm going to click over and see if anybody emailed me anything. Let's see. Hang on. All right. All right, so let's go ahead then and switch. Last question, just so that we know what it looks like. I made sure that I went on and again, just tried to find questions that might kind of bother you just with the way it looked. And that's this guy right here. And it's interesting because of course, I'm going to give you a second to, and I'm going to zoom in a little bit more so you can see that. One of the things that I thought was interesting is this idea that we've got these lines on the outside that really don't exist, but we want to make sure that we remember that in an obtuse triangle, those guys are actually called altitudes. Those guys are called altitudes. And we don't really see them all that often unless we're talking about area or the height of our triangle. So those are actually altitudes. And I wanted to make sure that I put that out there in order for in order for us to kind of keep track of what we're doing. So here we end up with the same setup as before. So we do have this time our similarity statement. So yay, we don't have to worry about the tick marks. And in case we keep forgetting that that's what that's called, that's our similarity statement. So it tells us what's going to match. And I want to figure out what the length of BC is. So this is the one right here that I need to figure out. And I think it's pretty self-explanatory what matches with what. So I'm not even going to go through the proportionality statement that I could write where I have AB to XY and BC to YZ. We can see that happening here. So again, just like before, however you want to set it up, I have a tendency just to keep moving left to right. So I'm going to set it up as BC would correspond with 9. And then I can see that this guy here on the outside, 11.4, does correspond with 8. So again, we're using our similarity statement to make sure that BC and YZ do match. They're the last two and the last two. It's obvious that our two altitudes will correspond. And then when we cross multiply, we have 8 times that segment BC equals 11.4 times 9, which is 102.6. And after we cross multiply, we're going to go ahead and we're going to divide everything by 8. And we find out that the length of BC is 12.825. And I am going to leave it as 12.825. I'm not going to round it because it is finite on the calculator. It's not a continuing decimal. There's no reason for us, if it doesn't explain where to round, to change that. So keep that in mind, that you can leave it just like that. So what we've taken note of is that you absolutely have changed nothing about any of this. It's just where those segments have appeared. So all of our scale factors will still be the same. All of our proportions will still be worked out the same way. Just make sure that you do have them set up appropriately. All right. So are there any questions so far on that? And if not, the only other thing then is I found 2 questions that had to do with our angle bisectors. And I'll keep checking to see if you guys have any questions. But it was the angle bisector stuff that I wanted to make sure that I looked at. Just looking to see if anybody was emailing me. All right, so for the first one, can anybody set up in the chat for me what the proportion would look like? I'm going to do the second one with you, but if you could please just type in on the chat what possibly our proportion would look like, and let me know. I know I saw a couple of them on the no reassignment, and I wanted to make sure that I did address them before I put that assignment live. I know I had that in there. Perfect. So when we had this, I'm going to agree if I do 15 to 9, it does have to be 25 to x. Now it could be 15 to 25 and 9 to x. I absolutely agree. So far I see everything perfect. There's not one fraction that looks wrong or one proportion that looks wrong. So that works out really well. Nice job. So we are going to go 15. Yep, I knew that was an equal sign, Elizabeth. You got that. So I'm just going to go ahead with 15 to 25. Not that the other 15 to 9 won't work. And because I chose to go that direction, we're going to go 9 over x. And we will cross multiply. Again, you could reduce and deal with smaller numbers, but honestly, it multiplies and divides itself out anyway. And we end up with 15x equals 225. And when we divide both sides by 15, we do end up with x equals 15. And we're done. So, seems easy. Now the trick over here is if you take a look, you had a segment listed, a separate segment listed. This guy was all by itself and this guy was all by itself. So when I look at the second example, and I saw a couple of these in the assignment, I have one here and one here. I got x here, but I don't know what this piece is. So I need to figure out what this segment right here is. How would I figure out what that missing segment is? Okay, now I will say I could see where 9, Caitlin, could be the idea that we're dividing it by 2. Remember, the angle has been bisected. Our side has not been split into 2. So, yep, we've got a couple 18 divided by 2. There's no tick marks down here. So we're not going to be able to say divided by 2. There is nothing that tells me these two are equal. The tick marks split the angle, not the sides. So these two sides are not equal. So what else could I do to figure out? So let's put it this way. If I knew that this guy was 4, how would I figure out what this side is if the whole thing's 18? Maybe that's a way to think about it. If I knew that this side was 4, and I know the whole thing is 18, how do I just figure out what this piece is? Nope, we've got to have a proportion, so I have to have this length given here. Let's see if I got scrap paper. So let's say I have a segment, just a segment, and I tell you the whole thing is 18. And we've got A, B, and C, but I told you this guy was 7. How much would AB have to be? Oh, good, there it is. 18 minus 4, 18 minus 4, good. But I don't know that it's 4. What I do know is on that segment, or whatever those letters are, if the whole thing is 18 and this is X, how do I figure out what that is? So So what would I have to write there if instead of 4 or instead of 7, I have an x? Good. So we now know that's 11. So we're doing this operation of subtraction. So because we've now decided that it's subtraction, and you've heard me obnoxiously now talk about it because of the delay, hopefully we'll kind of figure out what do we have to do then if it was 18 minus 7 got us that, or 18 minus 4 got us that. What do we have to write down here? Perfect. Good job, Caitlin. So over here, we need to call this 18 minus x, the same way we did 18 minus 7 or 18 minus 4. Nice job, Potts. So before I do anything, I need to fill that piece in with 18 minus x. Awesome. So I saw this question a couple times, and I wanted to make sure that we talked about the fact that subtraction is going to have to come into play before we do this. So keep that in mind as we're working this out. To use the correct proportion, we definitely need each segment. And that's why we have to make sure we use that subtraction. So now we're ready to actually do the problem finally. And I'm going to just go left to right. It seems just natural. When we read, we go left to right. So I'm going to do 14 over 20. And then I'm going to set it equal to 18 minus x over x. Again, segment to segment, segment to segment. When I cross multiply, we end up with 14x equals 20 times 18 minus x. I can't forget to write that as a quantity. I am going to distribute to each of these. And we have 14x equals 360. 18 times 20 is 360 minus 20x. I'm going to go ahead and add 20x to both sides. And we end up with 34x equals 360. We are going to divide by 34, and already there are some of us that are very much not liking this because it's going to be a fraction and it's going to cause some issues. We're not liking fractions. But I could go to my calculator and do 360 ABC 34. And that could, when I push equals, reduce it for me. I don't have to know how to do that. So I would find that this would equal a 10 and 10/17. If I don't want to write it that way, 360 divided by 34, I could always give as the approximate value of 10.58. Entirely your choice. So with that being said, I wanted to make sure that anything that I did see that kind of stuck out, we gave it an opportunity to go through. I am going to update some stuff just in the classroom so that you know what to look for. And hopefully we can attempt to do Zoom tomorrow. Otherwise, we'll just give us some time to ask questions and see where we're at. So if you have any questions, please continue to email me, continue to ask. I'm going to stick around here for a couple more seconds just to make sure that you are comfortable with what we went over today. I'll check my email one more time. But again, with the delay, I don't want to rush away if you have any questions. All right, everybody. Have a great day.